Will Fowler, and working along with Kyle, if he wants to introduce himself. But we both worked on this educational module for self-driving cars using Donkeycar.
Yes.
And yeah, so I guess maybe we should introduce ourselves a bit. I'm a undergraduate student from Tufts University. Came here to do this internship during the summer with Chameleon, and so I'm here presenting part of that module that we made.
Yes, hello. I'm Kyle Zhang, another one of the undergraduate students, and I came from California. I was at a community college, and I got the, blessed opportunity to come here to work on Chameleon and autonomous driving. I can go to the next slide. Okay, so firstly, we want to talk about some of the rationale behind why we created this Chameleon Education Initiative. So we wanted to make edge computing more accessible to beginner learners because a lot of the current learning material can be quite daunting for newcomers. Also, we wanted to make an educational module that has hands-on tutorials that go over both the theories and concepts that you do learn within a classroom setting as well. We wanted to make something that you could self-pace yourself or self-pace a classroom. So it can suit different levels of experiences and learning speeds. So, we can accommodate a lot of different diverse individuals. We want to inspire new ideas and applications because we really want this educational module to be a jumping off point for various projects and intellectual curiosity just in general. And we want to give access to a broad knowledge of technology as a tool in order to better people's lives through like Chameleon or Chia Edge or learning about machine learning. And we wanted to be able to provide it in a way that was free and open source, which is, that's what Chameleon Education is, right? It's an open source educational module for teaching cloud computing concepts, ML concepts, edge computing concepts, and so on and so forth. So in regards to what Chameleon is a NSF-funded cloud testbed. It supports computer science research through cloud infrastructure, and it provides incredibly customizable configurations and bare metal nodes that you can use for training. And it's really helpful in an educational setting as well, which we will get to later on. It has multiple different nodes, node types, so it has a very diverse range of nodes, and architecture is available so you can really configure it to your needs. And so it's very clear to see that this is very easy to support with disability and education. Will, do you want to go on with this?
Yep. Yeah, so within Chameleon, we have the Chia Edge testbed for all your Raspberry Pi or Jetson Nano devices. Chia Edge is great to use. Some of the advantages are being able to bring your own device. So you have maybe however many Pis you have in your classroom, you're able to enroll those directly into Chia Edge so that you have devices that you control in the testbed. Another thing is that this Chia Edge has great compatibility with the rest of Chameleon, whether it's the testbeds at University of Chicago or at TACC. By using Chia Edge for our Pis and other Chameleon services for maybe using GPUs, you can really accelerate the process of whatever projects you're trying to do by using these two services interconnectedly. And then lastly, multi-tenancy with Chia Edge just makes it easier for students to reserve devices that are enrolled. So you could imagine that in a classroom where you were maybe trying to do something with a bunch of Raspberry Pis, rather than just giving the Raspberry Pis to the students and just telling them to figure it out, the Raspberry Pis can be added to Chia Edge beforehand so that now the setup process for students is a lot easier. They can just go on and reserve it. And so that's Chia Edge. Next, we have Donkeycar. Now, this is the kind of like software that we use for this project to make our self-driving cars. you see there we have the little picture of our car. Scale model car is equipped with a camera, and in this picture that has like a Jetson Nano. But back to Donkeycar, it's a open source machine learning program for small self-driving cars. It's available for like hobbyists, students, contributors, whoever wants to use it. It's very easy to use. One of Donkeycar's strengths is that it makes setting up all the self-driving framework very easy. It does a lot of stuff for you, like training the models and collecting all the data. Donkeycar also has a very active like community of supporters. Since it's open source, there's constant development going on to improve the project. They have a Discord server where you can ask a bunch of questions, and they're very helpful. So you might ask me if Donkeycar is so great. Well, what did we do to kind of improve this and improve the usability? We really seek to lower the knowledge barrier with our module on using Donkeycar. One of Donkeycar's limitations is that they don't have as extensive as a documentation. So, and we're going to get into this a bit with our Git book, but we provide a lot more documentation on how students can complete this self-driving cars project. And we kind of, using Chi@Edge, make it a lot more easier for students to get past the first hurdle of like setting up everything with their pies. And so, yeah, that's Donkeycar. And then Kyle, why don't you take this one?
Yes. So in regards to the Donkeycar educational module that we were doing, there's a lot of things that the students can learn from this and a lot of classrooms that it can be adapted to. So just a brief overview of what they can learn. They can learn edge computing and robotics concepts, how to work with a Raspberry Pi, like SSHing into it, remote host connections. They can also learn about machine learning driven applications, and not just, the theory behind it, but like actuate it in the real world, right? You have a physical car with you, or perhaps a simulator, which we'll talk about later on. And you can really see how the concepts that you have been learning apply to the real world in a really, physical way. They will also learn the drawbacks of poor data collection, the utility of data augmentation and transformations, what are the differences between those as well. They will learn about analysis of the models and how to do so. And they can also learn more about Unix commands, because there's a lot of Unix commands used in the process of Donkeycar self-driving. And so, yeah, the little chameleon says, and more. So this is not everything that you'll learn, but this is just a little, taste of what you can learn through it. So now we will go to the Git book, and this is the main interface at the moment for our educational module, just, for accessibility purposes. Okay. And so this is our Chi@Edge education initiative, and it just kind of goes in the very beginning over some of the rationale behind the why we are creating this module and this initiative. So it's built on the NSF-funded Chameleon testbed, and we aim to provide free and accessible education for individuals of all backgrounds and skill levels. We hope to inspire other NSF testbeds to create similar education initiatives and to benefit society by spreading knowledge and lowering barriers. So once you get into this website, just into this Git book, you'll notice immediately there is 4 pages on the outer layer, and there is a README, because this README is very important on knowing how to navigate the Git book. So the most important part is this diagram right here. On the outside, you can learn about how to contribute to the community, how to provide feedback, but then the actual educational module is here. So these are gray at the moment because they haven't been created, but once they're created, that would be black. And right here we have the first module, autonomous cars, and that splits off into 2 pages. One is for educators and on how to set this up for your classroom, and one is for self-learners. And then they come back together, and a TA guide is provided. And it's not all inclusive, like not every possible scenario, like if you want to use this for a very particular classroom or you have a very specific way of teaching, then this TA guide can be changed and modified. It has a markdown file within the Git book. So this, is really, really adaptive to your situation. But also we provide a multi pathway system. So if you're in a classroom setting, then you can choose to click on the classroom pathway, and everything in it is self-contained. You can go, if you start from the beginning of the classroom pathway, you won't really need to click on anything else, and you'll be able to do it. And that's the same thing with digital and regular. And we will show some of the differences between the different pathways, and the reasons why, the rationale behind why we created our education module in this way. And just some stuff regarding contributions. We have a GitHub repo, and you can just fork it and then push it to us if you want to make any contributions. In regards to feedback, we have a GitHub discussions page. At the moment, it's empty. But if you guys have any discussions that you want to have, or any questions or concerns that you have about the modules, then here is where you can do it fairly easily. And now getting into the actual educational module itself. So right here, this is for educators, right? So instructions for educators and TAs that utilize this model as part of their courses. It goes over briefly what the regular pathway, the classroom pathway, and the digital pathway is. In the classroom pathway, it presumes that TA is present to take care of the edge, cloud, and hardware components of this project, because usually in a classroom setting, you want to focus on a very particular portion of this Donkeycar project. You do not want them to be going to go do cloud computing infrastructure while you're trying to teach them machine learning. And the digital pathway provides, a simulator that your students are able to use. Perhaps there is an issue with space, or there is an issue with getting the actual hardware. Then you can use the digital pathway and skip all the hardware portions altogether. And the self-learner is essentially the same thing as for educators, except that this does not presume that a TA is present to do some of the heavy lifting, or a teacher is. And so going into the pathways, you see right here, there's a TA guide. It's just a one-pager on how to prepare everything. And it makes things easier in the classroom, because, some of this stuff is adding a Pi and leasing Chameleon node, which, as we stated previously, you might not want your students to be doing this. So going into the classroom pathway. So this is a pathway that the students that created this educational module underwent and encompasses the most material. So there's some optional background information, but it might not be necessary for you, for your students, if that is not part of their curriculum. For example, edge devices, machine learning, you could choose to not have the edge devices as a background page if you are teaching a class in machine learning, like intro to machine learning. So some of these pages are labeled TA because these are specifically for the TA to do, like buying the cars. There's some links to the cars here. There is a page on adding the Pi and leasing the Chameleon node, because that might not be something you want your students to undergo. It might take up time that you could be teaching them more in-depth machine learning concepts or something like that. Yeah, so right here, there is information on how to use the Chia Edge docs or the BooleanNet etcher in order to etch your SD card, which is a necessary step with using the Raspberry Pi. How to install the SDK. These are all things that are important, but definitely sometimes out of the scope of the classroom. So we take that into consideration. Assembling the car, and here is where the students start to really get engaged here. this is a page on car calibration. Every car is different, even if it's from the same manufacturer. So perhaps you want to make sure that your throttle and your steering is actually done correctly, so it doesn't kind of overdrive or underdrive. That's what they can do. And then they can start collecting data, right? There's very, very detailed documentation on the exact steps that the students can use in order to do this project. And we feel like this is really important because as students who were not exposed to this before, we had a lot of things to learn. And so we were able to provide very, very detailed in-depth instructions on exactly the components necessary without a lot of the fluff or the confusing instructions from the original documentation. There's tips and tricks, and also there's an FAQ later on as well. We tell you exactly how much data is necessary, how to store the data, and how to make sure you clean it up. In this one, tells you how to clean the data. And then there is a training process, and the training process utilizes and leverages the Chameleon Cloud, which provides you GPUs that you can use to quickly and easily train the model so that you don't have to wait on that process. Everything is regarding the logic of training is contained within Donkeycar itself. So there is no setup of the backend necessary. And syncing the model to the actual car after you trained it, and then finally running the model. And we also provide extension projects because there are a lot of possibilities. For example, Will at the moment is working on an encoder, which is just a device that translates the rotational motion of the car into an actual speed. And I myself am working on adding cloud capabilities to the inferencing of the car. So these are all types of extensions that you can build on top of the existing educational module. And they can be really cool capstone projects that the students can really get engaged in. And then there's the digital pathway. The digital pathway is slightly different than that of the classroom or the regular pathways. The regular pathway just encompasses everything. So the stuff that the TA would be doing, the learner will be doing. So in the digital pathway, there's a simulator setup. It uses Unity in order to set up a simulation environment. And everything else is fairly similar to the classroom pathway. You collect the data, you clean the data, and then this does not assume that a TA is present. So you will have to reserve a bare metal node, or you can adapt this entire pathway to fit your classroom needs. I know that in some institutions, there's very little space to be actually driving a car around or creating a track. So perhaps a digital pathway would be best suited for that type of situation. And then this digital pathway can also extend further because the extensions present within the classroom pathway include everything, but specifically for digital pathway, the simulation environment begs the question of sim to real gap, right? Translating the training data of a simulation environment to that of real life. So that could also be a possible extension that you can utilize from the digital pathway. And then there's just going to be frequently asked questions. These are some of the fixes that we had to deal with. I have a MacBook and Will has a Linux computer. And some of the problems that we encountered was on my end, when I tried to flash the SD card, I could not find it on my computer. Like Finder was just not able to see it. And we figured out that that was because of the way that the SD card was partitioned. So a lot of these types of things that we had to deal with and we didn't know the issues with, these are included within the FAQ, frequently asked questions. And then here are just some references, some resources that we used in the creation of this module. And finally, we have the resources section, which provides you links to the GitHub, to the discussion, to Chameleon Cloud, a getting started documentation, and additional documentation. There's even a sample data because if there are situations in which you do not want to actually collect the data yourself and you just want to have something available. So that's within the resources section. And I would like to show you some of the some time-lapse videos of the process. So here's Will building the car or rebuilding the car, I should say. So there's no sound. It's just him quickly assembling the car. The process is not very long. It's quite a short process, even when it's time-lapsed. And you'll see that everything, if you buy it from Waveshare, everything's encapsulated within the package itself. So, you can just assemble it. It shouldn't take too long for the TA as well, either, because we have incredibly detailed documentation on how to assemble this as well. So that's the end of that video. And here is a demonstration of Donkeycar. Oh. And it's just driving around the track, kind of sporadically with this model, but there's various models. And then down here, we have data collection and then model testing. Donkeycar provides various different models, and you can use it to teach about neural network architecture. There are a lot of CNNs in here, but there's also RNNs. So the impact of sequence length or whatever could be something that you use this educational module to teach them. So this would be a linear model time-lapse video. And then here is a 3D model. This is also a CNN, but it's a three-dimensional CNN that has time as a dimension. And the performance of the cars varies based on various parameters. So I'm going to stop sharing if I can find the button. Okay. And Will, do you want to take over from here? He's going to show you the Trophy artifacts and how that integrates with the rest of our education.
All right. Okay. Yeah. So that was the Git book, and the Git book has a a lot of great documentation for that. But we also have our Trophy artifact here, and hold on. Okay, not see my. Oh, it was actually like sharing my entire screen. Okay. All right. Cool. So from the web page I have up right now is that link to our Trophy artifact here on Chameleon, and you come to this page, and this is important. And so I'm going to show you what you would find inside this artifact. We open it up, and we have the Jupyter notebook. And so Chameleon has a built-in Jupyter interface to use the Jupyter hub and run some commands to help you reserve hardware and spawn containers. So this is an important part of this project, to add the Pi to Chi@Edge and creating the container on there, and then also reserving the node that to use for training. And so you can do all these things through the graphical user interface on the Chameleon dashboard. But what we did is made this Trophy artifact, which has scripts that automate that entire process. So this would be part of the project. So included in the Git book would be a link to this Trophy artifact, where the TAs, if it's in a classroom environment, the TAs would be setting up the Raspberry Pis to Chi@Edge and the bare metal nodes for training. So I just opened up these two scripts, reserve Pi and reserve bare metal. And so these are the two most important things in here, since this is what will help reserve your Pi on Chi@Edge. So for this script, we're assuming that the Raspberry Pi has already been added to Chiat Edge, and so you would just need to make the reservation for it and spawn the container. So all the students would need to do, or TAs would just need to go through and run these cells, perhaps like changing a bit information, like in here, if you wanted to make the lease for a longer amount of days, you could change that. Maybe your device is named something different, they would have to change that. But for the most part, this really just automates the entire setup process for it. And then down here, this will create the container. Don't worry about this error. I think it was just there from me running it the last time. But we provide the specific image to use for the for Donkeycar, so that they can spawn a container which already has Donkeycar pre-installed. So no installations necessary. All of the dependencies that Donkeycar requires are already installed through this image in the container. We also make sure to set up all the ports that get needed, and including some device profiles for like the camera and the GPIO board. So after that cell's been run, the students can access their container through the Chiat Edge dashboard by just clicking on the container and going to the console. However, I also include a bit more here about setting it up to let the students SSH to the Pi through their own computers. There might be the case where that's like makes it easier for the students to use it on their own computers rather than using it through the Chameleon dashboard. And so we're just providing a bunch of documentation here about how to set that up. And then the last part that happens is if to still make the process a lot easier, it also can spawn a Jupyter notebook on the Pi that you can use through your own computer, and that makes it a lot easier to basically run commands or editing any Python files for that. And that's pretty much it. Just the rest here is kind of telling you what to do to access it. It's a very similar story for the bare metal node that gets used for training. One things that might get changed is the specific node type down here. It might depend on which one's actually available, like what you might want to use. For instance, when we were training, we would sometimes be able to get this V100 GPU, which would be very good. It would make training very fast, but you would have to look at the device calendar to know if that's available. And so that makes the reservation. Then down here, we create the instance, and also associating a floating IP, doing all the things that you would normally set up through the Chameleon dashboard, but just making it an automated process. We also make sure to set up SSH for our Chameleon node so that students can get into the node through their own computers. And then similar to the Pi, we also have something to set up a Jupyter notebook through the on that node, on that bare metal node, so that you can use it through there. And again, continuing the trend of just automating everything through this script, the rest of these scripts here pretty much run the commands that, for instance, install Donkeycar, install all of the dependencies for it, and then also installing, if you're using a GPU, you may need to install these CUDA drivers. And so that's what these code cells would do. And then the last part down here is just uploading your floating IP and being able to connect to the Jupyter notebook. So basically the point of using Troby for all of this is to just make everything as automated as possible and kind of remove any possibility for just getting any kind of confusion while using Chameleon, but also making sure that everything is standardized, right? So like by running these scripts every single time, you're always going to get the same machine with the same settings. So you're not going to get any kind of unexpected results. And so Chovy, as opposed to Gitbook, kind of takes advantage of the fact that it's actually connected to Chameleon's Jupyter interface, and you have the ability to run commands with it. Also in Chovy, we include our entire Gitbook module that Kyle just showed. To open it up, these are all printed out as markdown files, and so if someone wanted to use this for their classroom, you would be able to easily edit anything in here, and you could create a new artifact from that. And so, yeah, that's pretty much what Chovy has. So going back to our slides here, I think next I wanted to show. Oh, we have this video, but I think Kyle already showed it. But I think this might be the last thing to talk about. Was just the autonomous cars project extensions. Kyle briefly went over this with how it was appeared in the Gitbook, but kind of the idea behind these is that it's possible these could be used as like additional homework assignments for students. It kind of draws on the idea that our original project with Donkeycar to set that up and do training and run the models could be used as like a jumping off point for students to like use what they just learned to tackle a new problem, a new one that's like related, and maybe they receive a bit less guidance, a little bit less help with these extensions, but it's kind of like allowing them to use what they learned on like a new project. And so we just include some like ideas of what you could do. And yeah, so that's all the slides we have. Maybe wanted to see if we had any questions. I'll go ahead and stop sharing. So yeah, I don't know if maybe like anyone wanted to ask anything in like the chat or.
Yeah, so if somebody has any questions related to the artifact that we just presented, feel free to unmute yourself, and you're free to ask us any questions regardless the project.
Again, if we wanted to, if there's anything that you might want to see again, just briefly go back to, just anything that maybe people want a little more detail on.
Someone.
Okay, so yeah, you can go ahead. I think.
Can you hear me?
Yeah, we can hear you.
So first of all, the chat is not enabled, so I think that the people cannot.
I needed to give you access to.
Okay, so very interesting. So thank you very much for this presentation. I was just wondering if, since I have not this car, so I have not the hardware, I just want to know if I should try what you call the digital path or the classroom path. So I'm a little bit confused about one where I have to start, where is the hello world example to start to play with this project that you show us.
Yes, I don't know, Kyle, if you want to talk about because you use the simulator a bit more about like when someone might want to use that as opposed to the regular pathway.
Oh, yes. So regarding the simulator, regarding the digital pathway, though the classroom and the regular pathway kind of assume that you physically have a car, because we physically have a car. But one of the things that Donkeycar has is that they have like a Unity game engine type of simulator And I thought that that would be a good inclusion because some situations in which you don't have the financial or spatial resources necessary for you to actually do, training with the actual car. I remember you asking something about a hello world. What did you mean by that?
No, Joe, I was just wondering where to start to play with this car, even if I don't have the car. So I think that you already answered me. So the digital path is the path that I have to follow just at the beginning of this new adventure, this new educational experience, right?
Yeah. Yes, that's true. You could definitely do that. So I will actually share my screen again and go to the digital pathway because I do remember I didn't talk as much as I could have regarding this. So right here is the simulator setup, right? And there are stuff in here that is unique to having a simulator. For example, the Donkeycar simulator is built on top of the open source gym. They don't have the zoo yet, but someone's actually building a Donkeycar for zoo. So, doing stuff with like reinforcement learning. So right here, you can, I tell you very specifically exactly what to edit, right? There's a config file specifically for Donkeycar if you're going to run a simulator. And this will be directly on your PC. You will not be doing this on a server, and you will not be doing this on a Raspberry Pi because you need the UI interface in order to actually drive the car. But you do need a controller. Well, you don't need a controller. You could control it through the web interface. However, it makes things a lot easier for you if you were to try and play around with this with an actual controller. So inside of the config file, originally it's set, Donkey Gym is set to false, and you're supposed to set that to true, and then add a path to your executable file that you download. I walked through the entire process of downloading and unzipping the simulator above here. So everything is self-contained. There should be no issues with the situation. And I also note that the simulator is best run with Python 3.9, 3.10. I'm sorry, 3.10 instead of 3.9, because if you have 3.9 installed, some of the dependencies are newer, and so it won't work. So I hope that answers your question.
Yes, thank you.
All right, so do we have more questions? Oh, somebody asked about the link to the Gitbook. So
I sent it into the chat.
You put it in the chat?
Oh, sorry. I sent that to host and panelists. Is there a way that I can send that?
Well, you can answer here, but we can also make a post with like all the materials that we shared today, and obviously the links that is for the Troby artifact and for the Gitbook as well.
Yeah, we can make another post on the education mailing list. Right? I can send them out. Yeah. Well, we'll send it out later with a through the Chameleon mailing list.
I'll try to post it here.
Yes. During the process of Donkeycar, regarding the 3.10 versus 3.9, you do set up a new virtual environment, but you need to either have 3.10 installed or specify that you want 3.10. Driving the car without the UI, we can do that. It is possible to do that without the web UI. However, it is most likely easier for you to drive it with the web UI. The web UI also allows you to change. So there's a drop down menu in the web UI, and you can say, for example, pilot steering, and that will make the AI take over the steering part, and you can just provide throttle, or you can make the AI just drive, all by itself. So
basically, I think you have more options to change the parameters or even change the modules that you're training, and then obviously the parameters for your experiment. So I think that makes things easier to navigate through it.
Yes, it's true. The simulator, you need the UI. It literally opens up a Unity game engine application in which you can drive around with your controller or through the web UI. So that part is kind of non-negotiable. But regarding the regular training process, it's definitely possible.
Okay, so I just posted the link in the chat as well, just in case, but we're gonna be sharing all the materials in the mailing list as well. Okay, so any other questions, feedback, suggestions, anything that you feel like as educators it's gonna make your life easier in case you want to use this artifact? And I don't know if you have experience before in something like this, but we try to put all these materials together in a way to help educators to go through this like in a very easy to follow instruction setting. And also we give like different options in case you just want to teach a particular path from the long tutorials, or in case you want to adapt this to your classes. So this is not only like for teaching machine learning, you can also use it for teaching maybe an intro to engineering class, maybe an intro to robotics. Yeah, so we're also open to feedback from you, and because we want to create a community, so that would be really good if we also get some feedback from the educators. Okay, so we have another question, I think.
Yes, it is regarding how we work with the images. So for the images, right? I can share the screen again I'm assuming that you are saying this in regards to how would we clean the images, right? Okay, so in here we have the cleaning of the data. And actually I should probably go to the regular portion. So in here, this can be done from, the Trophy has a remote SSH connection to the Pi. And right here, we have cleaning. So this is the how to clean the data, right? So you can run this command from within the Donkeycar itself, the Raspberry Pi, and you can say Donkeycar tub clean, and then you can provide the file path. And then you can open a web browser, like just on here, and you can just enter the edge device, the edge device's IP address and use the port 8886, and that opens up a web terminal, a web interface that you can use to clean the data from. In terms of other ways to work with the data, in terms of like transformations or augmentations, that is something that you can mess with from within the code itself. It's a configuration. So there's a myconfig file in which those are applied. So I hopefully answer the question regarding that.
All right. Maybe, Massimo, you were also asking probably if we are collecting data in real time. So that's basically what we are doing with the camera. So you have the Donkeycar set like all the hardware together, and then you start like some sort of communication with it, and you interact with it through, you can use the joysticks like the regular controllers, but also you can use a web UI that you can use it in your computer. And I think we don't have the UI in the presentation, but we can definitely add that as well, like the options of how to control in the card. I think that's like a totally valid screenshot that we should add it in the documentation.
Yeah, and I just like to add that like the Donkeycar, it saves all the images from the camera pretty much automatically. So there's like nothing extra you have to do to set that up. It'll save the image along with the steering and throttle values as you're driving.
Yeah, actually, when we were going through the process of cleaning the data after collecting it, we were a little scared about the process of tub cleaning because the images themselves were not deleted from the repository. Instead, there was like a manifest JSON file that said that specifically named the deleted files. So in the process of training, they're kind of skipped over. But if you wanted to restore them, you can just change that. And that's all done within the Donkeycar terminal.
All right. Any other questions? All right. So I think we are all the questions covered so far. Kate, do you want to say something, or you can just?
No, all I have to say is fantastic job. Great presentation.
All right, sweet. Okay, so we are gonna close this webinar now, and we're gonna be sharing all the materials that we share today in this presentation, and also the link to this presentation. So it's recording, so we're gonna make it available as well. And thank you so much for your time and for attending this webinar. We very much appreciate it.
Thank you very much.
Thank you.
All right. Bye.
Bye-bye. Thank you.
Thank you.